Good morning, campers. Morgan here, tuning back in with some information about weak acids. And what's going to be happening today is that we're going to see the equilibrium chapter meet the pH chapter. Okay? It turns out to find the pH of a solution, we have to take the negative log of the H plus ion. Except what if that acid doesn't fully dissociate? HCN is not on our list of strong acids. It's a weak acid. It only partially dissociates. And based upon the value of the Ka, it doesn't dissociate much at all. That's 10 to the negative 10. So the Ka equals the concentration of H3O plus times Cn minus divided by HCN, and that's 6.5 times 10 to the negative 10th. Okay, so we do our ice box here. We have 0.20, we can ignore this, 0 and 0, minus x, plus x, plus x. This should be looking pretty familiar to you. 0.20 minus x and x. So plug it into here, we have x squared over 0.2 minus x equals 6.5 times 10 to the negative 10. Okay? It's pretty small, I can approximate it. X squared over 0.2 is about equal to 6.5 times 10 to the negative 10th, or x is equal to about 1.1 times 10 to the negative 5th. We're going to let x equal the concentration of H plus. Therefore, the pH is the negative log of 1.1 times 10 to the negative 5th. That comes out to be 4.94. Now, 2 sig figs based on this having 2 sig figs and 0.20 having 2 sig figs. Probably be a good idea to go back, check your percent ionization, make sure it's less than 5%, but with a K this small, it's absolutely less than 5%. Okay? Now, why don't you go and try the other two, because it really is quite a bit of review. Tune back in when you're done. All right, welcome back. So, for number 2 here, the acetic acid dissociates. Typical icebox. 0.1 minus x, 0, 0, x and x, Ka, values small enough we'll be able to approximate. We're going to approximate all of these, don't worry. Okay, go through, solve it. X, which is the H plus, is 0.0013. Okay, therefore the pH is the negative log of 0.0013 and equals 2.88. Now for number 3, this is borderline meeting a quadratic, but when they did put HF on the AP exam, which has a similar Ka to this one, it makes a different acid than this, but it's a very similar Ka, they said approximations were fine, so I'm not worried about that. Practically the same setup again, and this time a pH of 2.03. All right. So go through, try the next couple on the next page, see how you do with that, and then we'll tune back in. Okay, so checking how we're doing on number 4. Hopefully you came up with a pH of about 4.03. And in number 5, you got a pH of about 2.11. Now this one does have about 8% dissociation, so I went through and I did this as a quadratic. By approximation you get 2.09, by quadratic you get 2.11. I think that's close enough not to worry about it. All right, so now what I want to do is just put a little twist into this. And this is not anything that's really going to kill you, all right? It's just slightly different definitions, okay? So we have dimethylamine. Now that is CH3 sub 2 NH. It reacts with water. It's a base. So we get hydroxide, and we get CH3 sub 2 NH2 with a positive charge. The K is pretty straightforward. You've got your hydroxide, you've got your CH3 2 NH2 with the plus, divided by your CH3 2 NH. Okay, going to do an icebox. 0.750, we can ignore the water. These are 0 to start with. Minus x, still keeping everything to 1-to-1 ratios for the time being. 0.750 minus x, x and x. So we have an x squared over 0.750 minus x equals 5.9 times 10 to the negative fourth. You can approximate this, no problem. So x squared is 5.9 times 10 to the negative fourth multiplied by 0.750. Okay, x equals 0.0210. Now here's where it's a little bit different. This is actually the OH minus concentration. You see, this produced an OH minus, which means we needed a Kb. And the Kb is what was given this time. If it wasn't Kb, we could find Kb from Ka. Ka times Kb is Kw. So what we actually end up getting is the POH when we take the negative log, which is 1.68. So the pH is 14 minus 1.68, which is 12.32. Okay? So this isn't really that much harder if you label everything. If you make sure you know you're looking for a Kb rather than a Ka, that hydroxide is the ion you're interested in, okay, etc., etc. Okay, that's our little tour through weak acids and weak bases. I hope everybody's having a good day. This is Morgan signing off.